Welcome, guys. So here is part one of the IS number 16 notes on hypothesis tests. Okay, so our setting starts out here asking, is Mrs. Bacula a good free throw shooter? Yes, I did play basketball back when I was in high school, and I was a pretty good free throw shooter. So I'm claiming right here, I'm claiming that I'm an 80% free throw shooter, which would mean that out of all of the free throw shots I could possibly take, I think I make about 80% of them. Obviously, that doesn't mean that every time I go out and shoot 10 shots, I make exactly 8. But if you looked at all of my shots, over time, I would make about 80% of them. So to prove my skills, I went out and shot 50 free throws. Okay, I shot 50 and I made 32 of them. So is Mrs. Bacula exaggerating about her free throw skills? Well, the first thing we would want to do is identify the population parameter, sample, and statistic. So I think the statistic is the easiest thing to find. It's what has actually been done. I made 32 out of 50 free throws. So my proportion of makes, right, my p hat, my sample stat here, it's going to be that 32 out of 50. And I'm just going to calculate that real quick to see what that is as a decimal. 32 divided by 50. 0.64. Okay, so my sample statistic is the easiest part to calculate. That's the 0.64. So then I'll think about, where did that statistic come from? What sample was that from? Well, I shot 50 free throws, right? So this is my 50 free throws that sample proportion is coming from. So then I think, what sample or what population does that sample come from, right? Those 50 free throws are a sample of all of the free throws that I could possibly shoot, right? So this is all possible free throws. And I'm not writing this on here, but obviously this is of the free throws that I would shoot, not people in general. So I'm talking specifically about my ability to be an 80% free throw shooter. So then let's talk about the parameter. This is P, right? P hat is the sample statistic. P is the population parameter for proportions. And so this is going to be the true proportion. See, I focused on how many I made versus how many I missed, right? And I want to talk about 80% made, so I'm going to focus on that. So true proportion of free throws made. I guess I should reference, for those of you who don't know basketball very well, a free throw is a set shot from a line that's, I actually don't know how far back it is, maybe like 16, 20 feet back from the hoop. And it happens whenever a foul is committed. You get to shoot free throws. If you're not sure and you're really curious, Google it, you'll find it. Okay, so let's think, now that we have all of our population, parameter, sample, and statistics set out, let's think about the two possible explanations for why I only made 32 out of 50 shots. Because notice, our sample statistic is 0.64. That would be 64% of the 50 shots were made. 64% is obviously less than 80%. So there are two possible explanations. One is that Mrs. Bacula, Mrs. Bacula is an 80% shooter. I really am an 80% shooter, but she had an off day, right? I just wasn't shooting my best that day, which we will call that variation sampling variability. So basically the idea is that some days I'm going to shoot less than 80%, but some days I'll shoot better than 80%, right? If I really am an 80% shooter. And they just combine to overall make me that 80% shooter of all my shots. Okay, so that's one possibility, that I really am an 80% shooter, but I had an off day. The second possibility is that I'm lying, right? That Mrs. Bacula is lying about my claim, aka she's not actually an 80% shooter. Okay, so this 64% make rate that I had in my 50 free throws here could be saying, or could be showing that I'm not actually an 80% shooter. I'm probably less than an 80% shooter, right? Since 64% is less than 80%. Okay, so those are our two possibilities. Before we move on, I want to ask some questions that I want you to think about, and then I'm going to give you the answer to. So my first question is, do we have some evidence that I, Mrs. Bacula, is less than an 80% free throw shooter? And the answer here is, yeah, we do have some evidence, right? In my 50 shots, I only made 32 of them. I only made 64% of them. So I have some evidence that I'm not actually an 80% shooter. But the real tricky question here is, do we have convincing evidence that Mrs. Bacula is less than an 80% free throw shooter? Right, and this kind of harks back to when we were talking about, is a value unusual or not? So that's basically what we're going to test. I think if I had made, 40 out of 50, that would be exactly 80%. You would not have convincing evidence that I wasn't an 80% shooter, right? That would fit in line with being an 80% free throw shooter. But what if I'd only made, let's say, 38 out of 50? That's still pretty close to 80%. So our question is 32 out of 50 low enough that it's convincing evidence that I'm not actually an 80% shooter? Could this happen by chance, right? And I'm still an 80% shooter, or is it so unlikely that it would not happen by chance, given that I'm an 80% shooter, and thus I'm not actually an 80% shooter? Okay, so to test my claim, we will assume, number one, we'll assume the first one, that she is an 80% free throw shooter, and examine the likelihood that she makes 32 out of 50 shots through a simulation. So we're going to use something that fits into 80% of the time it is a success. So we're going to use the spinner provided to simulate those 50 free throws shot by an 80% free throw shooter. Again, we're not necessarily assuming that these are free throws I'm shooting. This is if the shooter really was an 80% free throw shooter by spinning 50 times. Okay, so let's look at this spinner. So the basic idea here is that there are 10 compartments, right? 1, 2, 3, 4, 5 on one half, must be 5 on the other, so there are 10. And so I'm just going to use my pen here to spin it, right? Super simple. So I need to either shade 8 of them to indicate makes, or I'm going to take the easy way out and shade these 2 as misses. Now, I totally could have shaded 1 here and 1 over there. It really doesn't matter as long as 2 of the 10 are shaded to indicate that those are misses. Okay, so I'm going to take my pen. Let's see if I can get this right. It's a bit harder to do with just one hand. Oh, I told you it's harder to do with one hand. Okay, and spin. All right, I'm going to go with the end of my pen that has the cap on it. So it pointed to a section of this circle or this spinner that is blank, so that means it's a make. So for my first spin, I had a make, and then I'm also going to keep track of my misses. Okay, so I would spin again. Oh, I'm only going to count the spins that actually stay on here. I should get a better pen to do this with, sorry. Hopefully you have something that's a little bit less unwieldy. There we go. Okay, so I landed on another make. Okay, so I'm going to keep doing this for 50 more times to get my total proportions of makes out of my total. Okay, so I'm going to go ahead and say that if we were doing this in class, I would give you time to work through all 50 of your quote-unquote shots, right? But since we are not in class and I can't gather your data in a meaningful way through our online portion right now, I'm just going to use the data from last year. So last year when I did this, the first time I went through the 50 spins, I got 41 out of 50. Okay, 41 out of 50 were makes. So I'm going to convert that to a sample proportion. 41 divided by 50. Okay, so I get 0.82. And then the second time that I went through another 50 spins to indicate another 50 shots, I only got 33 out of 50, which gives us a sample proportion value. Let's see, it's really close to our original one. 33 out of 50 is 0.66. Okay. All right. So then I was asked to, I asked my students to put all of their sample proportions on a dot plot on the board. So they came up and, for example, for me, I would have put a dot for 0.82 and a dot for 0.66. So all of these dots represent a simulation of 50 spins and then calculating the proportion of makes for the different students. And so each of my 30 students did 2 of them, so there's a total of 60 dots here. Okay, so the first thing I think about when I look at this dot plot is that it looks normal, right? It kind of has that bell shape. It's approximately normal. It looks like there's maybe one outlier out here, but it definitely looks approximately normal. So let's make sure we clarify what each dot represents. So just like I just said, this was a simulation of 50 spins, but those 50 spins are representing free throws. So each dot represents the proportion of free throws made, right? I'm interested in the ones made from a sample of 50 free throws. And this is important, that are shot by an 80% free throw shooter, right? It's not necessarily me that's shooting these, because I might not necessarily be an 80% free throw shooter, but this spinner does represent an 80% free throw shooter. Okay, I'm gonna underline that just to indicate that that part is really important. These are actually shot by an 80% free throw shooter. And we're gonna use them to determine whether it's likely that I would have actually gotten 32 out of 50 had I been an 80% free throw shooter. So the next question is, what percentage of the dots represent a percentage of 64% or less? Okay, so here's 0.65, that would be 65%. So this dot is the 60.64. Okay, so that dot, or less would be to the left, so it's all the dots over here. Remember, I'm including the 64%. So it looks like that's just 2 dots. And again, there were 2 sample proportions simulated by 30 students, so my total is 2 times 30, or 60. Okay, so to find the percentage, I take my 2 that are less, 64% or less, and divide by 60. 2 out of 60. Okay, let's see what that is. 2 divided by 60 is 0.03333. I'm going to round that to just 0.03, and it asks for a percentage. So notice I'm writing an arrow, not an equal sign, because the decimal is not equal to 3%, but it is equivalent. So it gives us 3%. Okay, and then it says interpret this percentage in context. Okay, so remember what our assumption was up here? We're assuming, number 1, that she is an 80% free throw shooter. So I'm gonna start with that. Assuming Mrs. Bacula is an 80% free throw shooter. With that assumption in mind, I'm going to talk about this percentage. There is a 3% chance, and in the future we won't talk about chance, we'll talk about probability, so I'm going to use that decimal as well. 3% chance really means a 0.03 probability of her getting, there's a 3% chance of her getting a sample proportion, oops, why do I spell proportion wrong? Of 32 out of 50, which of course was 0.64. So there's a 3% chance of getting that sample proportion of 32 made out of 50 total shots, which is 60 or 0.64, or less, because less would be even more extreme from what we would expect, right? We always put that or more extreme. So it's always going to be or less. Sometimes it'll be or more, but you always have to write one of those two. In this case, less than 0.64 would be more extreme. So a sample proportion of 32 out of 50 equal to 0.64 or less, purely by chance, right? In that first assumption, we're assuming that she is an 80% free throw shooter, and these results just happen by chance. So that percentage tells us the likelihood that that would happen purely by chance. Ooh, 3% is pretty low. So let's move on to this next question on the back. Just one more question before we switch videos here. Number 8 says, based on your answer to question 7, does the observed p hat equal to 0.64 in result give convincing evidence, right? Before we just had evidence. Now we're seeing if it's convincing that Mrs. Bacula is exaggerating, or is it plausible that an 80% shooter can have a performance this poor just by chance alone? Okay, so plausible is a different word than possible, right? It is possible. Obviously, right? It might be really, really, really unlikely, but it is possible. The question is it plausible, right? Is it likely to happen, or at least not so unlikely that we don't believe it? So in this case, because, and I'm going to call this something new. I'm going to call it the probability value, which of course writing probability value out every time is going to get annoying. So instead I'm just going to say the p-value. And I'll write that on the previous page in a second, because the p-value of 0.03, right, that probability of this happening purely by chance is called my p-value. As I write this sentence, I'm going to fill in how it could be different. So like in this case, the p-value is less than what I'm looking for, but it could possibly be greater. So I'm going to use these backward slashes to indicate the different options in this sentence. So because the p-value of 0.03 is less, or it could be greater than 0.05. That's our typical value that we look at. I'll explain why 0.05 in a minute. We either do or do not have convincing evidence that Mrs. Bacula is not an 80% shooter. Remember that this last part is the assumption in number 2. That's what we were trying to see if we could prove. She is not an 80% shooter. Okay, so let's walk through this. The p-value will change, right? So because the p-value of 0.03, that's what we have to find. We used a simulation on the previous page to find that. We'll do something different in the future. Just to get an idea of where that p-value comes from. So because that p-value is less than 0.05, right? 0.03 is less than 0.05. We do have convincing evidence that Mrs. Bacula is not an 80% shooter, okay? If our p-value had ended up being higher than 0.05, then we would not have convincing evidence. But since it is less than 0.05, since it's pretty unlikely, right? 3% of the time it's pretty unlikely, we do have convincing evidence that Mrs. Bacula is not actually an 80% free throw shooter, right? We have convincing evidence that she is actually less than an 80% free throw shooter. Okay, I'm going to stop here and then we'll do the big ideas and check your understanding in the next video.